Hello, everybody. So today we're going to continue with Module 16, Lesson 16.3, and we're going to be discussing box plots. And our essential question is, how can you use a box plot and measures of spread to describe a data set? So sometimes you'll hear box plots referred to as box and whiskers. So box and whiskers. So let's look at this. A box plot is a display that shows how the values in a data set are distributed or spread out. To make a box plot, we need to find 5 values for the data set. We'll find the least value, the lower quartile, the median, the upper quartile, and the greatest value. Now, the lower quartile, we find that by finding the median of the lower half of the data. And for the upper quartile, we find the median of the upper half of the data. And so we'll practice that today. So example 1. So the heights of several students are shown. So I wants us to make a box plot for the data. So these are the students' heights, and we need to order the data and find the needed values. So let's put the numbers in order from least to greatest, okay, because that is one of the values we have to find, right? We have to find the least value and the greatest value. So let's go ahead and put them in order as they've got here. So remember, to find the median, we take off one from each end until we get to the middle value. Sorry. So we're down to 59 and 60 in the middle. So that would be 59 and a half for the median. All right, so now the lower quartile would be the lower half of the numbers, the median of the lower half. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to find the median of just the lower 6 values. So we take away from the ends, take away the next ones, and we notice that we're in between 56 and 58. So our lower quartile would be 57. And then the upper quartile, 60 to 65, we take off the ends, take off the next two, and we notice that we're left with 61 and 62. So our upper quartile is 61 and a half. Okay, so now we found all 5 values. Now we're going to draw a box plot and draw a number line that includes all the data values. Okay, so our least value was 54. So we would start our number line at 54, and our largest value was 65. Okay, so we need to have a number line that includes that. It can be, you can count by twos, all right? In this case, they're counting by ones because there's only 11 values. Oh, it's actually 12 values, right? All right, and so on the number line, draw dots above the least value, 54, the lower quartile, which was 57, the median, which was 59 and a half, the upper quartile, which was 61 and a half, and the greatest value, which was 65. Okay, then draw a box around the lower and upper quartile and draw a line, vertical line, through the median. Attach the two extreme values, the least and the greatest, with a line segment to the upper and lower quartiles. Okay, so that's basically what a box plot looks like. And so if you hear the terms box and whiskers, the whiskers are basically these sides parts, and they represent the extremes, the furthest parts away, the lowest and the highest value. All right, so let's go ahead and try some problems here. So in the example, what percent of the data values are included in the box portion? And then what percent are included in each of the whiskers on the end of the box? All right, so let's turn that over and look at it. So in the box, we have values from 57 to 61 and a half. So how many of those values what percent of those values are inside the box? Well, 58, 59, 60, 61, 62 is outside the box. So we have 2, 4, 6 values. Well, 6 out of 12, that's 50%, right? All right, so the box makes up 50% of the values. The outside numbers, okay, so the numbers outside the box would be less than 57 and equal to or greater than 54. So that would just be these bottom three. And then on the other side, we want values that are bigger than 61 and a half. So 62, 63, 65. So 3 out of 12 on each side, right? So inside the box, you'll have 50% of the data. On the lower portion, you'd have 25% of the data. And on the upper portion, you'd have 25%. All right, so now let's make a box plot of the daily high temperatures as shown. All right, so step one, we want to put the numbers in order. Okay, so the smallest value is 75, then 78, and there's actually two 78s, then 79, 80, and 83, 84, 85, 88, 89, 92, 94. So 12 numbers. Let's verify that. 2, 4, 6, 8, 10, 12. Yes, so we've got them all listed. So our least value is 75. Our greatest value is 94. So put 75. So each of these lines is worth 2, right? So 76 would be in between 74 and 78. So 75 has to be between 74 and 76. $94 would be right there, right? Okay. So we've got the least and the greatest. Now we need to find the median. So let's cross off from the ends and work our way towards the middle. So those two, then these two, then these, then these, then these, and we've got 83 and 84. So the median would be between 83 and 84, so 83 and a half. Okay, so here's 82, and that's 84. So 83 would be right in the middle of those two. So 83.5 would be a little closer to the 84 mark. I'm going to draw a line through that because the median, we put a line. So now we have to find the lower quartile and the upper quartile. So there's 12 numbers. So we're going to find the lower 6 and the upper 6. 1, 2, 3, 4, 5, 6. Okay. So the lower quartile, work our way towards the middle. We're in between 78 and 79. So 78.5. And the upper quartile will be the upper 6. So cross off the ends and work our way towards the middle. We're in between 88 and 89. So 88 and a half. Okay. So that's basically what our line plot would look like. I mean, our box plot. I'm going to go ahead and write the values. Least was 75. Lower quartile was 78.5. Median was 83.5. The upper quartile was 88.5. And the greatest value was 94. Okay, so we get all that information from the box plot that we drew. Okay, so now finding the interquartile range. So we know that the range is the difference between the highest value and the least value. So interquartile would be simply subtracting the upper quartile and the lower quartile. So a measure of spread is a single number that describes the spread of a data set. One measure of spread is the interquartile range. The interquartile range, abbreviated IQR, is the difference of the upper and the lower quartile. So here is a box plot that compares the age of dancers in two different dance troupes. So we have Group A, whose median age was 21. The lower quartile was 20, and the upper quartile was 24. In Group B, the median was 23.5. The lower quartile was 21.5, and the upper quartile was 26. So what is the IQR of both? So Group A would be 24 minus 20, because this is 24 and this is 20. So we're just going to subtract those. So the range of the quartiles is 4. And then B, we're just going to subtract 26 and 21.5. And we get 4.5. So why do we want to do that? So if we compare the IQRs, interquartile ranges, we can describe the distribution of the ages in each group. So Group B has a slightly higher spread. So the ages in the middle half of Group B are slightly more spread out. There's bigger gaps between the smaller amounts and the bigger amounts in that group of ages. All right, so let's practice ourselves. Number 3. So the box plots compare the weekly earnings of two groups of salespeople from different clothing stores. Find and compare the IQRs of the box plots. Okay, so the IQR of A is 1500, 16, 17, 18, 19. So each line is 100. 16, 17. So 1800 is the upper quartile of A. Now we're going to take away the lower quartile, which would be 1100. So they have a difference of $700 in the middle 50% of the group. Has a difference of $700. Group B has an IQR of Group B, 16, 17, 18, 1850, and the lower quartile is 1400. So its difference is $450. All right, so which one is spread out least? Well, Group B is, right? Because its interquartile range is smaller than Group A. right, so to summarize that, when we're comparing the two IQRs of Group A and B, Group A has a greater spread in the middle 50% of the weekly earnings. Remember, their interquartile range was $700, while Group A was $450. So basically all that's saying is that the gap between the top or the middle 50% of the earners of that company is closer together than it is in Group A. All right, finding the range. So where I mentioned that the difference for a range is just the difference between the highest and or the greatest and the least value. And so example 3, the data sets show the ages of the player on 2 professional baseball teams. Find the range of each set of data. So Team A, Team B. We want to put these numbers in order from least to greatest. Could you just go through the list and find the least and the largest? You could. Okay. But typically we'll be also finding other sets of data. So putting them in order is valid. So Team A, they've listed it for us. It goes from 21 to 39. And Team B, their numbers go from 21 to 31. So Team A has a range of 18. And Team B has an age range of 10. So the range of ages for Team A is 18 years, while the range of ages for Team B is 10 years. That means that Team B, the players are closer together in age than they are in Team A. All right, find the range of data of each set of data. Which city has a greater range? So Miami and Chicago. Okay, so Miami, and we're going to put them in order from least to greatest. Okay, so 76, 78, 78, 80, 82, 83, 84 and 86, 87, 89, 90, 91. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. Okay, so the range of Miami is 91 minus 76 for a range of 15. So the difference in temperatures between the high and the low of their monthly high averages is only 15 degrees. Okay, Chicago. Put them in order from least to greatest. All right, so the range of Chicago's temperature, after putting them in order, we have a low of 31 and we have a high of 84. So 84 minus 31. So a difference of 53 degrees. Okay, so what does that help you know? Well, if we notice here, we notice that Chicago has a greater variety or extremes between their high temperature and their low temperatures there's a greater temperature difference. Whereas in Miami, there's only a 15-degree difference in the months. You're going to get a low of 76 and a high of 91. In Chicago, it gets as low as 31 and as high as 84. Okay? So there's a big gap between their low temperatures and their high temperatures. All right, number 1. Order the data from least to greatest. Okay, so we have 4, 10, 11, 13, 14, 15, 25, 29. There's 2 33s, 35, 43, 51, 58, 64. Okay, so 2, 4, 6, 8, 10, 12, 14, 15. All right, so we have 15 numbers. The greatest is 64, and the least is 4. Find the median. Median is the middle value. So with 15, that means there will be one exact number in the middle. So cross off from the ends until we get to that middle value. $29. All right, so 29 is the median value. What is the lower quartile? So if 29 is exactly in the middle, there should be 7 numbers on the lower half, 2, 4, 6, 7, and there should be 7 on the upper half, 2, 4, 6, 7. Okay, so let's find the lower quartile by finding the median of the lower half of the data. So cross those two out, cross those two out, cross those two out, and we're left with 13. The upper half, cross off those two, cross off those two, and we're left with 43. And now make a box plot for the data. So the median is 29. All right, so 29. The lower quartile is 13. The upper quartile is 43. And we can put a box around those and draw a line, vertical line through the median. What's the least value? Well, the least value is 4. And the upper value is 64. All right, what's the interquartile range? Well, that would just be 43 minus 13, which gives us 30. The range is 64 minus 4, so a difference of 60. How's the range of a set of data different from the IQR? Basically, it's how it's found, right? So range right? So range is the difference between the highest value and the lowest value in the data set. And the interquartile range, or the IQR, is the difference between the upper and lower quartiles. So remember that the interquartile range makes up the middle 50% of the data. So we want the range of we're basically finding the range of the middle 50% of the values. When we find the range of the whole data set, we're including 100% of the numbers. All right, let's look at 469. Number 9. All right, use the data set of the heights of several different students and draw a box plot of the data. So first thing we want to do is go ahead and put the numbers in order from least to greatest. So we're going to start with 45, 46, 47, then there's 3 48s, 2 52s, 56, 57. Okay, so there's 11 sets of numbers. Okay, so that means how many students are included in the data set? 11, because there's 11 heights recorded. All right, so the median, let's start with the median by crossing off from the ends until we get to the middle value. Those two, the next two, next two, next two. We're left with 48. So 48 is the median. The lower quartile, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the lower 5 and the upper 5, we need to find the median. So cross off from the ends, and we get 46 for the lower quartile. And the upper quartile, we get, cross off those two, we get 52. We're going to box that information from the lower to the upper. We're going to draw a line through the median, and then we're going to put the whiskers on. The whiskers is the least value and the upper value. Okay. So what method could have been used to collect the data? I don't know. Students could have measured each other. The teacher could have measured the students. Okay. So the teacher could have measured and recorded each of the students' height. What other data could you collect from the students to create a box plot? Provide several examples with units of measurement if applicable. Well, this could be several different things, right? I don't know, maybe shoe size. Maybe a person's weight. I don't know, pounds, kilograms. Maybe somebody's age or a group of students' ages. Maybe a GPA. Okay, so on. So anything that you think you can measure. All right, so our 13 through 15 use the box plots of the total precipitation for the same group of cities for the months of January and June. All right, so in January, we see we have a low temperature of a low precipitation amount of 1.3 inches, and we have a high of 2.5 inches. The median rainfall is 1.8 inches, and the lower quartile is 1.7, and the upper is 2. So what's the interquartile range for January? Well, we have 2 minus 1.7, so 0.3. In June, we have 2.3 for the upper quartile, and we have 2 for the lower. So it also has a difference of 3. What's the range for each month? January, 2.5 minus 1.3. So a difference of 1 and 2/10 inches. And in June, we had a high of 2 and 4/10 inches and a low of 2 inches. No, sorry, a low of 1.9 inches. So difference of half an inch for the range. So compare the IQRs. What can you conclude about the two data sets? Well, they're equally spread out, right? Okay, since they both have the same interquartile range, then the how they're spread out in the 50% of the data, remember the box makes up 50% of the data, then the difference is 0.3 in both of them, so they're evenly spread out. Compare the ranges. Well, there's a bigger difference in January than June. So So the spread in January is almost, or the range of the data in January is almost twice as much as June, right? Or it's actually over twice June. So it's the difference between the highest amount of rainfall and the least is greater in January. You have a greater fluctuation between greatest and least. All right, 17. Can two box plots have the same range and IQR and yet represent completely different data? Explain. Well, let's just look at this. These two had the same IQRs, right? But their numbers were different. Could we still have the same difference of ranges? Sure. What happens if the high and the low are actually the same? It could be. So yes. All right. So yes, because it's the difference between the highest and lowest values. And so the differences could be the same between different sets of numbers. So for instance, what if I had a low of 5 and a high of 12? Well, the range would be 7, right? But what if the other set of data had a low of 1 and a high of 8? The range is still 8. Still 7, because 8 take away 1 is 7. All right. So it's because of this, just the difference. When you subtract those two values, they could be the same. All right. 18. So Matthew collected data about the ages of the actors in 2 different community theater groups. He drew a box plot for one of the sets of data. So looking at this, it looks like 32, 34, 36. Each line is worth 2. So it looks like the median was 32. The lower quartile was 26, and the upper quartile was 54. The greatest value was 60, and the least value was 22. So our youngest actor was 22. The oldest actor was 60. So find the median, range, and IQR for each set of data. All right, so those were south side players, and we have to do north side players. So we have to do both. So what's the median of the south side players? 32. What's the range? 60 minus 22, 38. And the interquartile range is 54 minus 26, so 28. All right, so now let's do the north side players. So the north side players, let's put them in order. We have 25, 26, 30. No, sorry. 21, 25, 26, 30, 39, 62, and then 2 actors are 63, and 71. So if I was going to plot this one, I would say the median is, cross off those 2, those 2, those 2, those 2. I would say the median is 39. Okay, so the median of the north side players is 39. The range, the age range is 71 minus 21. So they have an age range of 50. And the upper quartile, 2, 4. Okay, would be 25 and a half. And the upper would be 63. All right, so the interquartile range of the north side players is 63 minus 25 and a half. Which would be 37 and a half. So B, suppose you were to draw a second box plot for the north side players using the same number line as the south side players. Which box plot would be longer overall? Which would have the longest box portion? Well, we did do that, and we noticed that the north side box is a lot longer, right, than this box. What that basically tells us is that this data is further spread out. Okay, so the north side players will be longer. And which would have the longest box portion? North side. Okay. Again, so when we look at the box plot for north side players, it actually almost takes up the whole number line. Okay, so it is a lot longer from the least value to the largest value. The box portion just itself is longer than the south side players. And C. Mandy assumes that because 9 data values are shown for the north side players, 9 data values were used to make the box plot for the south side players. Explain why this is not necessarily true. Well, they're averages, right? So a box plot can't tell me how many values there are. It can only tell me 5 important pieces of information. It can tell me the lowest value. It can tell me the highest value. It can tell me the median, but I don't know how many numbers there were in order to get to the median. So any number of data would give a median. Okay, even 3 values, I could find a middle number. 2 numbers I can find, well, there's really not a, because that would be half. But 3 I can find a median. Okay. So I could, any number of data values would give a median, lower, and upper quartiles. So therefore, you can't tell by just looking at the box plot. So again, any number of data values would give a median, a lower and upper quartile. And you can't tell just by looking at the box plot how many values were in the original data set. Okay, so she can't make that assumption. All right, so that's it for lesson 16.3. In our next lesson, we'll talk about dot plots. So until then, I will see you soon.